one thing that's really cool is that we've set up the Ethernet infrastructure to support all of our VLANs and the access port assignments and so forth before we ever started touching the routers. It's really important to have a good solid infrastructure of Ethernet and switches so that you can plug your routers into that. So our next task, which we look at the task 2, new category, it's LAN IP addressing and routing. 2A says this: create a custom IP addressing plan that will allow for each VLAN to support up to 30 IP devices in each subnet and keep all of the subnets inside the range of 10.126.0.0/24. The subnet should be created using and used in the following manner as provided in the table. So in the table, it wants us to go ahead and have the first subnet available assigned to VLAN 10, and the next one for VLAN 20 and 30 and 40 and 50. So how do we carve this out? Now we're doing the same exact number of hosts per subnet. So one way of figuring this out would be to reverse engineer it and say, okay, well, how many hosts do I need? I need 30 hosts. How many bits do I need to leave at the very end of the IP address for host bits in order to get 30? And the answer is 5. So if we leave 5 bits for host bits, and we take the additional 3 from that octet, the high order 3 bits for custom subnetting, our new mask would be /27, which represents the first 24 bits of the first 3 octets plus the first 3 bits of the last octet. And from that, because the least significant bit of the mask is in the 32 position, our increments for the subnets are going to be 32s. So the first subnet is subnet 0. It's really our first available subnet. It's 10.126.0.0/27. They call it the subnet 0 because all of the subnet bits, the first 3 high order bits of the last octet, are all zeros. Hence it gets the term the 0 subnet. So it's our first subnet, which is the 0 subnet, is going to be this guy. And the next one is going to be a .32 because our increment is 32. The least significant bit of the mask is 32. We simply increment that for every new subnet. So subnet 32, subnet 64, subnet 96, and subnet 128. So the first valid host, which, by the way, leads me into task 2B, is write out what the subnets will be right here, and in addition, identify what the first and last usable addresses will be for each of the subnets. Now this lab is assuming you've been all the way through CCNA, ICND1, ICND2, or the compressed CCNA, whatever, and that you understand custom subnetting. This lab was not designed to teach you from the scratch, from ground zero about custom subnetting. So if you have questions or need to revisit some of that content in either ICND1 or ICND2, I would strongly recommend you buffer up those skills. Go on the Cisco Learning Network, ask questions, make sure you're clear on how they operate. So what would the very first address be here? Well, the first address is one more. It's always one more than the network. So the first IP address would be 10.126.0.1. The last IP address would be the next subnet minus 2. So the range here is .1 through 30. For the 32 subnet, the range would be 33 through 62. The 64 subnet would be 65 through 94. The 96 subnet would be 97 through 126. And the 128 subnet would be 129 through whatever the next subnet is, minus 2. So if we add 32 more onto 128, that would be 160. So the final range would be 2 less than that, which would be 158. So there's our subnets that we're going to use. We've also identified the first and last valid IP addresses on those subnets. And that is, my friends, task 2A and 2B. Our next task is 2C, and that is to configure R1 to perform inter-VLAN routing for the 5 subnets that are created, the VLANs 10, 20, 30, 40, 50. Use the information in the table regarding the IP address assignment for the sub-interfaces. And right out of the dock, it's got FA00.10 being used for VLAN 10, FA0020 used for VLAN 20, and all the way through 50. So a couple things here. On this interface, FA00, the first thing we need to do is make sure that it is no shutdown to bring it up. Second thing we're going to do is carve out sub-interfaces by telling each sub-interface exactly what VLAN it's in charge of. so that when the switch, which we'll also have to configure for trunking, when it sends frames tagged for VLAN 10, the router will know exactly which logical subinterface is supposed to go ahead and process that. So the biggest trick here is getting on the right device. So we'll go to R1, and on R1 we'll go into configuration mode and go into Fast Ethernet 00 right here, and we'll tell it that we want it to be up and active with a no shutdown command. Once it's up and active, we can then go ahead and carve out the sub-interfaces. Reality be told, we could carve out all the sub-interfaces first, but before any of them would work, we would need to go to the parent interface and tell it, hey, you need to come up. So sub-interface FA00.10, we're going to have that watch .1Q tags of 10. And you don't have to have the number of the sub-interface match the VLAN you're matching, but it's darn convenient. That way when you see an interface, you'll know exactly which VLAN it's responsible for. And we'll assign it the first valid IP address from this subnet for the 10 subinterface. For the VLAN 20 subinterface, we will assign it the IP address of 33, the first valid IP address. For the .130 subinterface, which is watching VLAN 30, we're going to have it, the first IP address in that subnet is a whopping 65. So we tell it you're going to be tracking VLAN 30 tags and your IP address is .65 with a /27-bit mask. And then the fourth network, which is going to be VLAN 40, subinterface .40, we're going to give it the first valid IP address, which is 10.126.0.97. And then last but not least, once we've got all that in place, we're going to go down to VLAN 50. Now, VLAN 50 is interesting. We didn't assign any access ports for VLAN 50. So how might we use it? Well, it is named management VLAN. And what we're going to do is we're going to use VLAN 50 for the management of our switches. So we'll give each of our switches a VLAN 50 IP address in their VLAN 50 interface, and that way we can go ahead and manage them on VLAN 50. Okay, so R1 is done. If we do a show IP interface brief, check this out. It's going to give us all the interfaces. Hopefully they will all be up, and there's their IP information. Sweet. So those are the first valid IP address available in each of these subnets. So that part's done, but you know what else we need to do? We need to go over to the switch to make sure the switch is configured to support it as well, because the switch has to trunk out to R1. So we're going to go to FA0/1 on switch 1 and configure FA0/1, this guy right here, as a trunk port. So from switch 1's perspective, it doesn't care or know that it's trunking any differently than it is up to these switches. It just knows that do your normal forwarding, and when you forward frames out FA01, you're going to tag it. And that just like it would up to switch 4, switch 3, or switch 2. And R1, looking at those tagged frames, knows which logical subinterface to process them on. So on switch 1, if we do a quick show, we'll do a show interface trunk. So here, if we do a show interface trunk, and it's going to show us that we're trunking on 19 through 24, switch 1 is, and also now on port FA0/1, which will support R1's subinterfaces. All right, task 2E. 2E says we want to assign the switches management addresses as shown in the table. In the table, it has VLAN 50 for each of these devices, and it's also showing that we want to use the, oh, this is fun. We want to use the 11th IP address in VLAN 50, which is our 5th network. We want to use that for switch 1, and the 12th IP address for switch 2, and the 13th address for switch 3, and the 14th address for switch 4. So what we could do is simply say, well, it's the 128 subnet. The 11th IP address would be 128 and 11 more, which works out to 139. So we'll go in and we'll create a brand new interface VLAN 50. The VLAN already existed. This is switch 1's logical layer 3 hook, if you will, into VLAN 50. And we'll give it the appropriate IP address, which would be .139. It's also asking us the next task to assign, or 2E later, to assign a default gateway to point to R1. So we'll do both of them. We'll assign an IP address to switch 1, And we'll say, by the way, switch 1, we also want you for a default gateway to use 10.126.0.129, which happens to be the IP address of the VLAN 50 subinterface on R1. So that part's done. We'll test that in a moment. Let's go ahead and do the same thing for switch 2 using the 12th IP address. So on switch 2, we grab the 12th IP address for VLAN 50 and plug it in. And we'll do the same thing for switch 3 and switch 4. So that's it for switch 2. Here's switch 3. Now he's done. Again, a VLAN interface is a logical layer 3 interface. You can't find it. If you look for it with the microscope, you'd never find it because it's a logical interface that the switch can use for communicating with other devices on that network. And IP default gateway is what we'd use with a switch that doesn't support IP routing. Multi-layer switches can do IP routing if we turn on that feature, but the IP default gateway command is what we'd use to set the default gateway on this guy if he is not configured to do IP routing. And then last we'll do switch 4. So on switch 4, configuration mode we go, interface VLAN 50 on switch 4, IP address of 142, which is the 14th IP address on this subnet, and we'll also specify a default gateway of 10.126.0.129. Now the very next task, by the way, 2F, says verify that R1 can ping each of the switch management interfaces. So I suppose we could ping from here as well. We could try a ping. We do a ping of this IP address. So we'll do a ping to 10.126.0.129. And if we can ping that, which is our R1's interface, I bet you R1 can ping us as well. So we'll go to R1 and let's do some pings. 139 was the first one. And since we haven't pinged him yet, we might lose some to the ARP cache or the ARP resolution. There's 140. And we're losing 2. It could just be we're timing out. Wow. 140 is not coming back. We'll take a look at that in a moment. And let's do 141. All right, troubleshooting. Oh, dang. Okay, the pings worked there, but I'll tell you what, the pings did not work for 140, and that would represent, that's supposed to be the IP address. This is 139. The R3 was supposed to use 140, unless I did a typo and didn't put in the IP address correctly. Let's go, let's check it out. Let's do that ping one more time to 140. And then we'll go investigate why he's not responding. So 139, 140 is switch 2, excuse me. So let's go to switch 2 and see what we did wrong. Oh, right there. Look at that. IP address. And I was just not even paying attention. I just put that IP address right in configuration mode and not in interface configuration mode. So let me clean that up. So one of the things I love doing is that whenever there is an issue like this where I totally just plugged in a value like the IP address wasn't in interface configuration mode, and that's what caused my problem. So let's go fix that. On switch 2, we'll go back into configuration mode, interface VLAN 50, and in interface VLAN 50 I'll put in the IP address. I wasn't even paying attention when it gave me the error, and we'll put in the IP address of 140. And I know the default gateway command, or at least I think it took, so I'm going to put that in again just for grins. And there's our config. All right. So now we should be able to ping that from switch number or router number 1. Go down to router number 1, do a ping to that same address, and hopefully this guy will shine through. There we go. Now that ARP has been resolved, we should be able to ping that and get 100% success to everybody. To 141, 142, 139, everybody. Everybody should respond. Okay, so that's it for task 2F, and that's the end of section 2. The next piece is our wide area network, which is starting with R1 to R3 and frame relay. It'll be a lot of fun. Let's jump in.